In the next class, we will be discussing the remaining part, the macro enumeration. With that, we have this type def declaration also. And another part which we didn't discuss earlier, that was this. There is our IO. This one. We discussed about console IO, but file IO part we didn't discuss. This one we will be discussing on Saturday. Okay. Right. So let us go there in structures. So here you see, this is our topic today. And this is what we are going to discuss. Okay. What is a structure? How to create a structure? Then some features are there, global and local. Then structure with or without a name, also known as a tag. Then how to declare structure variables, how to initialize structure members. Now, when memory space is allocated for structure members, we'll talk about that afterwards. Okay. So because structure is not an ordinary type of data. So there is some difference in case of memory allocation of structure elements and structure variables also. How to access structure elements. Then what is an array of structure? How to create an array of structure. Then how to make a pointer to a structure. Then how to access structure elements using pointers. Another part we'll be discussing, which is how to pass a structure through a function. That means how to use structure as a function parameter. Function parameter or function argument. Okay. So these are the things we will be discussing. First part, what is a structure? So this thing we have already seen. User-defined data type, there is a structure. Now, structure and union, they are almost identical. Okay, what is union? What is the difference? That we'll say afterwards. Okay, there is not much difference. Whatever, that much we'll discuss. Then the structure, of course, there is an advanced data type. The idea is concept of creating your own data type to store more complex pieces of information. Now, how to define them? To store multiple data items in one variable and create, initialize, and modify variables of these new types. This is what we will be discussing. Okay. Now, this part, this is not we will be discussing, so it is in red. It is so-called linked list. Okay. Now, let us move further and see how the structure is created. Now, what is a structure? Here, the user creates his or her own data type. Okay. So these are the primitive data type, and using primitive data type, we can derive these data types. And then we have the advanced data type, which are user-defined. The structure is one such. So a structure gives the facility to create our own data type. So take a note that structure is not a facility to create a structured data type. The structure is a facility to create a new data type as per the requirements of the user. Okay. So that way, a student can be a data type, a bank account can be a data type, and so on. So we'll see this thing further. Now, what is structure? It holds multiple data items. Now, these multiple data items, they are dissimilar in nature, right? When these data items are a single type of data, in that case, we can use array. So that is the difference between array and structure. In case of array, the array holds a particular type of primitive data, okay, within it. But in structure, it holds multiple data items which might be different. Okay. This is the difference. Now, a pointer to a collection of members in memory. So there is a structure pointer. Entire structure may be passed as function argument. Possible pointer to structure may be assigned. Note, structures cannot be compared using this equal to assignment structure or this structure. This is allowed. Now, array versus structure, this is what we'll discuss. Unlike array, structure, name isn't an address. Okay, this is also another difference. And this thing, array and static, but structures not. This means when we define an array, this array name is the memory location of that array. And that memory location becomes a static one. Okay, but structures, they are dynamic in nature. So their memory address cannot be accessed directly after creating the structure. Okay. Rather, the memory address of a structure doesn't mean anything. Rather, this is the memory address of the structure variables. Okay. This is the thing, how to declare structure variables. We create a structure. Okay, so a structure is basically a data type. Now, that data type, say for example, student is a data type. Now, we have to create the variables of type student. So what will be the memory address? It will not be the memory address of the student structure. Rather, it will be the memory address of student 1, student 2, etc. Similarly, for bank account, it is like that. Bank account 1, 2, 3, etc. So this is the difference. The structures are not. The struct comprises multiple data types, which known as the member. So these terms you should note carefully. When we create a structure, that structure usually have a name. That is the new data type we have created. We have created a structured data type. Now, that particular data type has some members. So these are the definition of the structure. Say, for example, if we create a student data type, the features of a student is name, roll number, year, etc., etc., right? So those are the members of the student structure type. But if this is a bank account structure, then the feature of a bank account is quite different. It's the name of the account holder, the account number, the amount he is having in his account, etc., etc. So those will be the member items of a bank account structure or bank account structure. So each member has its own unique name and a defined type. Right? That you understand? Student name, student roll number, student name is character or say string, roll number, integer. For bank account holder name is string, account number, integer, etc. So each member has its own unique name and a defined type. The student may have members name, which is a string character array. Now age, which is integer. GPA is in double. Okay, it can be. It is not an integer, right? Now the gender or sex, that is a character. Only M or F will do. So this is character. Now, whatever major subject, etc., etc. So these are the members of a student structure. Let us see what is the generic way of creating a structure. Struct is the keyword.
Sir, someone is trying to join.
Oh, just a minute. Tell him, try once again. I am not seeing him. Tell him to try once again.
Yes, sir, I've told him.
Yeah, Devjit Das, right?
Yes, sir.
Devjit Das has joined. Okay, fine. So let us continue. Yeah. So this is the generic form to define a structure. This is the keyword struct to create a structure. Now struct the name. This name or tag, whatever you say. Then this is the member. The members of that particular structure. Now this structure has a name. That means they are members of this named structured data. Yeah. So if this name is student, then the members will be different. If this name is bank account, then these members will be different. You understand that? So for each of the members, what we need to specify is the data type of the member. So it can be integer, it can be char, it can be string, etc. And this data one means the particular variable name of this type 1. If this is a point, we will say this is an int x, this is an int y. If it is a 3D point, we will have another one, int z, which are the xyz coordinate of a point, of a 3D point. So, data 1, data 2 are members of name. Clear? The name represents this structure's tag and is optional. Although it is optional, it is always better to give a name tag to a structure. Otherwise, you can also create a structure without a name, but that would be a trivial one. Okay. So we'll see also how to do it. Okay, so if we do not provide a name here, now you see one thing, in this format we have not mentioned any structure variable. Here, structure variable means a structure named this particular name. Okay, so that we can do afterwards. So that is what we will do with reference to this name. We will say struct name student 1, student 2, student 3, etc. So those student 1, student 2, student 3, they will be the variables of type this particular structure. Okay. But that facility we won't get if we do not provide this name or tag here. In such case, what will happen? So we do not have any name here. After the declaration of these members, structure members, we will list the variables. Right? So in that case, let us not give a name and directly here let us put, say this is a student 1, and student 1, student 2, etc. etc. Okay. So that is a trivial way, and the disadvantage is that you won't be able to add any more variable to this structure type because we have no name. So those are trivial types of structure definition. So we can also use type def, but type def has a different use also. That we won't discuss right now, what is type def. So now structure declaration, this is format, although in this format what we omitted is the list of variables. So this is the complete declaration, struct, this tag is same as the name, the member list means this one, and the variable list. Okay. Variable list means, see this example, new 1, new 2. Okay, disregard type def. Struct new 1. Oh, it has already given this name. New 1 in is smaller case, this capital 1, whatever. We could have omitted this new 1 also. Simply struct int character star key, and the variable is new 1. Anyway, this is the general form. Now we have the option of specifying the variable list afterwards. This is the form to create the structure with a name. So separately, we can list this variables to that particular. So what is this? Here we see this in structure declaration. This is the most general type, and now take a note that from this general type we can omit the tag or name. Okay. So for example, this is a struct, it has no name. Okay. These are the members and these are the variables. So X and Y are structure variables which will comprise of three components, two integers and a character pointer. Okay. Now here you see what is omitted is the variables. This variable list is omitted here, but afterwards we can also use what are the variables. So we'll make struct S and this Z will become the structure variable for structure named S. And of course, obviously, in this declaration, okay, we don't need to specify the members because members has already been specified. Okay. So these are the ways we can define a structure. Okay. Let us not discuss type def now. Can be omitted. This is what we have already discussed. Okay. So this is important. Point is this point here. This point is defined with this name tag. Right? So we can use it afterwards to define more points. Now here this is not named, and this P1 and P2 they are declared at the time of creating this structure. So there is no way of adding more points here, P3 or P4. Okay. There is no tag, so there is no way to reference more examples of this structure. So it is always better to make use of this general type. Make use of this general type. Whatever. So this is how we create a structure. But next, there are some examples also. First one is student info. So these are some examples you would be understand these things. Okay. Second is student grade, whatever. Then there is a bank account, student record. Okay, let us see now. Ajay, by the way, we take a note that when we have created these structures, this structure means a structure data type. The name is bank account. There is no memory address which is generated for this bank account structure data type. Okay. This is only some declaration part. It remains there. But then when we will
specify the variables, okay, then only the memory will be allocated. This is what we are going to see now. Let us see. So this is an example where our struct type is a student. The student characteristics are provided by his or her first name, then last name, birth year, average grade. So this is what you understand, and also you take a note that this definition of student structure, okay, this is a global, because this is mentioned, this is declared outside the main. So that way, if we declare it within the main, it will become local to that main. So this is the way you know how we do for any variable. So for a structure variable also, if it is declared outside the main, it becomes global, or inside the main or inside any function, if we define it, it becomes local to that function. Now let us come within our main function. So this main function defines what it defines. First of all, the student structure variables. You see, in this declaration, we didn't declare any structure variable. Right? What we declared is the name of the structure data type and the members. There are 4 members, but the variables are not named here. So that naming part is done within the main. So what is me? Me is a variable of type struct. Which struct? A student type struct. So what is a student type struct? That is already declared here. So what we need to define here? We need to define the first name. Now, you take a note. So this me is a particular student struct variable, and it contains these 4 data. Those are, this first name is Petra, last name is Taylor, birth year 1989, and average grade is 3.5. Take another example. Here, this is another variable. This variable name is U, and first name Remy, this is Sarah, birth year, and average. Okay. So this is basically assigning values to student member variables. So now what happens when we define these variables? These variables are defined means we have defined values for this member item. Right? So what is Petra? This Petra is the variable first name. Right? This Remy is also the variable first name. Okay. So we have a confusion. Both are first name, but to take a note, this Petra is first name for the variable me, and this Remy is the first name for the variable u. So this gives us a way to distinguish between the first name for me and first name for you. Let us see how this can be done. Let us print. Okay. Let us print these student details. Okay. So printf names, and here, but here is int. This is double. So there is an error. It should have been percentage. This should have been %d, right? Because this is int and this is double, so this should have been lf. Anyway, so what it will print?
না
This
স্যার
content-
নামগুলো তো পরপরই আর বাকি একটা পরে
Oh, okay. I understand. Right. So this is okay. So these are only the names, right? So this is okay, right? And now you see how this first name is referred. So they are referred in conjunction with the struct variable. How they are conjugated? This is the way we conjugate a variable and its member. And this is known as a dotted pair. You see first variable and the first member. They are associated by this dot. Okay. So this is known as the dotted pair. And you understand now, these items are also the dotted pairs for first name and last name of our student variable, me and you. Okay. And in the second line, we have that birth year, and third line, we have average year. Okay. So now this is clear. So this is how we access a particular member of a structure variable. Then also you take a note, this is the way we assign values to a structure variable. And this is the way we take out the values for that particular structure variable.
স্যার ওই অ্যাভারেজ গ্রেডের পার্সেন্টেজের পরে দুইটা দেওয়া কেন স্যার?
Oh, this is basically LF. That means it will give you 2 decimal digits. Okay.
ওকে স্যার।
Just a minute. In that case, 3.5 এখানেও তো একটা 0.2 হবার কথা ছিল। Yeah.
হ্যাঁ স্যার, ওটা পয়েন্টটা পড়েনি বলে অনেকগুলো ডেসিমেল দিয়ে দিয়েছে মনে হয়।
Exactly. Right, you are. Exactly. ঠিক. Okay. So the point is that up to this declaration, there was no memory allocation. Up to this declaration. Okay. So from here, if we try to find out what is that ampersand and the student, it won't give anything. It will give an error message. The compiler will give error message. But now, after this definition, after this assignment, then we can find out the memory location of first name for this particular variable. What it would be? Ampersand me dot first name. That will give us valid memory location. Is it clear now? So that is why this struct is basically a dynamic structure. And the memory location comes when only we assign values to the member elements of the structure. Okay, so this is clear. Next, assigning struct student, struct student. We know what it means. To access a particular member, use the dot operator. That is what we have already seen. So here, this is a 2D point, so we can get back the x coordinate of point P1 by using P1 dot x, and the y coordinate will get P1 dot y. Similarly, here also we get this thing. To access this reference it by the variable name. Okay, this is what we have already discussed. We can only access a struct by its variable name. Okay. Legal operation on the struct are assignment, taking its address with ampersand, copying it, passing it as a parameter. Okay. So here we have declared point as a struct with two members x and y, and then we have created the P1 as a point structure, and then you see the initialization of this variable P1 is done here. P1 is 5 and 10, which means this x will get value of 5 and this y, P1 dot y will get the value of 10. And P2 equal to P1, it is possible we have to create a point P2 also, then we can do it. So this is what is possible. And what we have seen is the use of dot operator, right? Now this dot operator is rather easy to access the member of a struct variable, but there is another way to access the member of a variable with reference to a pointer. In such a case, we use this arrow operator. See later that we also use arrow operator to reference a field if the struct is pointed to by a pointer. So, we know what is a pointer, so that way we can create a pointer to a struct, and with reference to that pointer variable, we can also access a particular member of a struct variable. For that, we use this arrow operator. So in connection with struct, we have these two operators, dot operator and arrow operator. And you will see in our earlier list of hierarchy of the C operators, these two are clubbed together, this dot and arrow. So they are clubbed together, and they are has a quite high hierarchy. A hierarchy level, they stand at above the midpoint, something, whatever. That you check 1 second. So this is the thing, our dot operator struct as parameter. Struct as parameter means as if we are sending a struct as to a function, okay? So struct may be passed as parameter, function can return struct as well. Now passing as a parameter, this is the declaration of a function. Okay. It has a output type void, so it won't return anything. But what it will do, it will print a point. Print a point means it will print the x coordinate and y coordinate of a point. And see the parameters here. They are struct point x, struct point y. Okay. Now, this x and y, they are point variables. So don't consider this x and y as x and y coordinate of the point. So this should have been P1 and P2. Whatever. Notice that the parameter type is not just the tag, but preceded by the reserved word struct. So this complete specification is necessary. Only point x, point y will not do. So this is something, the syntax of the language. We have to follow it. And returning, this is not returning any struct, but it uses a struct variable as a parameter. It processes the struct variable within itself. There is another example, another type of example where a function can return a struct. So here you see what is the output type. The output type is a point structure, struct point. Okay. So this void was the return type. For this, what is the function name here? The function name is create point. Okay. What is the return value? A struct named point. Okay. What are the parameters here of this particular function? There are two integers. They are a and b. Okay. So what is done here? Declaration is also given here. Declaration and definition. Another point variable, struct point variable, temp is created. And then this temp dot x, this becomes a, and temp dot y, it becomes b. So that means if we pass coordinates of a point to this particular function, it will return the struct point with those two integer values. So return temp. So the calling function will now get this struct point with the members, the necessary member for the variable. Okay. So let us see this particular one is shown here. You see, this is the definition of the or declaration of the struct, global declaration. The point is the name of the struct which has two members, integer type. They are x and y. And we have two functions. Okay. The function declarations are here. One is a get struct, other one is the output. Both have a parameter of type point struct. Okay, struct point. Now, in the main, we are creating a point. Here, again you see y. Here is a point. Okay. Should have been p1, p2, etc. Anyway, this is not a good way of using this variable name. Anyway, understand y is a point. The coordinates are 0 and 0. So get struct y. Get struct means what? It is now the execution will pass here, get struct. Right? Where is the definition? Get struct is here. So here the argument struct point p, what is this p? This y 0 0 is coming here. Right? So this point p, now you see this p dot x, okay, is becoming 0, right? Because this p is now this y, which is 0 and 0. Right? So this p dot x is basically 0, and this is the scanf part. Okay. Now, as it is scanf, that means we are free to provide any value here also, right? And then this is scanf p dot y. So here also we are free to provide any value for this y coordinate. Printf p dot x, p dot y. What it will print? Anyway, you try to run this particular code and see what happens after this printf. And when it is getting input, even if we give some input other than 0 and 0, it is not coming to the main. Right. And here what happens? This output y, again it goes there. It prints p dot x, p dot y. That means it will print 0 and 0. Anyway, what is the use of this? Anyway, just for practice, you try what happens here. What next? Struct as parameter. This is what we have already discussed. Pointer to struct, right? Right name. Okay, pointer, the whatever. I am not going to discuss this. I have to see this, whatever. How we create pointer to a structure. This arrow operator we have discussed. Access member pointer, we have defined the structure. Say we have a structure point like this. Define a structure variable which is say P5. So struct point, this is the members and the variable is P5. And this is a pointer variable. This PTR is a pointer variable of type point struct, point type structure. Okay. And to access this PTR, what is this PTR? This is ampersand P5. So memory location of this point P5 we are getting in PTR. Now use arrow operator to access struct members. Now with this PTR we can get back this X and Y. How it is done? This is not the thing. Access that. Some example. Where is it? So this is a particular example how we get back the member of a particular structure variable by this pointer operator. So this is how we have to create this. Where is pointer definition? Whatever, you need to study this. I haven't seen that one. Pointer based example. You see this thing, okay? You would be able to understand. Then this is a particular problem on structure. So here, we try to solve this problem. The thing is, you have to create the tomorrow's or the next day, given the today's day or date of today is given, and what the function will return is the next day or tomorrow's day. So the function name should be advance day. And now you see here what is given is that date structure definition. The structure date is given. It has a year, month, and day. Here, you have to take into account the month end, the year end, and leap year effect. Okay. Again, you note the month end effect it depends on the particular month. Like January has 31 and February has 28, but for a leap year, February has 29. Then March, April has 30. These effects you have to consider, and the input format is year, month, and the day. Output format is month, day, and year. Let us see some examples. If input is 1, 2, 3, which means what is the year? Y is 1. So it would be output as 0001. Okay. Right. And the month is 2. Okay. Month 2 means in output month will come first. So this is 2. And then this 3 here, this is the day. So this 03, this is the day. So which one is the next day? The same month, 02, advance the day by 1, 04, the same year. This is rather clear. This is also clear, but take a note here. This is a month end. Okay. Day is 31. 10 means it is October. So next day would be 1st of November. 11/01/2018. So this is the effect of month end. What next? This is the effect of year end, right? 31st December. So this 2018 is becoming 2019. So this is what you try to do using a struct named date. Okay, here we have another concept. This is known as structure boundary alignment. It is basically like this. Say we have a struct, forget about type def. First one is named align1. Members are first a character, integer, again a character. You see, we have another struct. This is named align2. Here we have int first, then we have character A and we have character C. Now, the question is, if we find out the size of these two variables of struct type align1 and align2, what would be their size? This is what is done here. The new1 and new2, they are the variables of struct type align1 and align2. They are initiated here. So new one is A, 10 and B, and new 2 is 20 C and D. Okay, so whatever, why X is required here? Something is confusing here. Why? This should have been new one directly. By the way, that is not important. You see what we are going to do from here. Say this X and Y, they are the variables here and they are assigned here. Okay. Now, you know, a character requires a single byte. Int requires, say, 2 byte or 4 byte, whatever. And again, a character, it requires a single byte. Okay. So, here, what would be our size of X? Here you see, the first one is 1 byte. Okay. Now this is integer, it is 4 byte. So in a memory, where it will be written? You see, let me show this. Now you see, say this A triggers 1 byte, it will come here. Okay, this is a character. Now, where from this particular int it will initiate? Will it initiate from here? It is not. It will initiate from here. Okay. The next one is again a character. So int x4. So here we have another character. Okay. So when we find out the size, what would be the size overall? Here, the overall size would be starting from here up to this. Okay, you understand? Why it is like that? Because nowadays we have a 32-bit system usually, or compilers have say 32-bit. Now a 32-bit means there are 4 bytes, is it not? 4 into 8, 4 bytes. So what these 32-bit compilers does, they read or write 4 bytes at a time. Really, that is controlled again by its speed. You know about clock speed and other things. So when it reads from memory or writes in memory, the chunk is 4 bytes. And to speed up the whole thing, what it does, when the first of this block, okay, is occupied, it moves into the second block. Okay, so this is the thing, and int say 4 bytes, it is completed. And again, we have a character here. So it will again take up this 4 bytes. So this size of would be 12 bytes. What will happen for this thing? Here, the situation is a bit different, right? So here, what will happen? This first one is int, right? First one is int, so this is int. It will take up 4 bytes. And 1, 2, 3, 4. Here we have a character. And then you see we have another character here. And this character now fits within the 4 byte. So it will come here. Okay. In the earlier case, this int, it will not fit within the remaining 3 bytes. So the compiler moved into the next block of 4 bytes. But here, these 2 characters, they fit because they require only 1 byte. And ultimately, what would be the size of this byte? So this is simply this 4 and then this 4. So it would be 8. Okay. So this is what happens. And this is known as boundary alignment. Okay. Nowadays, memory requirement is not that critical. But previously, there was a lot of problem with memory availability. So you see there is union. So here comes the idea of union. So if you convert a struct into union, in that case your memory requirement reduces. Okay. So this memory requirement will reduce if a struct is converted into an union. So that is the idea of union only. Now this is an example of nested structure, then array of structure, what other things. Now, this is also a very important problem. Here you see, here consider a triangle. So, the triangle consists of 3 points, and what you need to test is given a point, okay, and 3 points, 3 corner points of a triangle, you have to find out whether the given point is inside the triangle. With an integer inside and call, this function should receive whatever. Anyway, this is a different problem. But somewhat a related problem, which is quite interesting, is this one: given a point and the corner points of a triangle. You have to find out whether the given point is within the triangle or not. So you may try to solve that problem. Oh, now this is the last topic today. This struct, okay, this is the concept in C. The equivalent concept in any object-oriented language, like in C++, or there are other object-oriented programming language. Java is there, some others are also there. So in those languages, the concept of struct is elaborated as an object. And that is why those are known as object-oriented programs. But the struct is the starting point based on which the object was created. Okay. Now this object-oriented programming, it has many features. Now out of which, I am not going to mention all these features. I only mention one thing, which is the encapsulation part. Okay. Is it written here? No. Anyway. No, here you see the idea is that, say if we have a point structure, okay, the members are two integers. If we have another struct which is a complex number, okay, so instead of point, if this is our complex number, what would be the members of this complex number struct data? You know, a plus ib is a complex number. So both are integers. So you see this point and this complex number, their members are identical. It can happen. Okay, that is fine. It can happen in many cases. The members are identical. But what is different here is that the operations on point, okay, what we do with points, we create lines and we find out the distance of the line, find out the angle of the line, etc., etc. Okay? And for a complex number also, what we do, we find out the argument. Then something we might have another complex number. We can add them, we can multiply them. Okay? So here, if you note that although the members of struct point and struct complex numbers are identical, the operations on these two items are different. Right? So in C, when we define a function corresponding to operation on points, they are either local or global or something which is visible to all programmers, okay, or something. It is transparent. The same thing is true for complex number also. The operations on complex number, which is created by some functions again. So So this is what happens in C. Now, what is the difference if we use this concept of object-oriented programming? So in object-oriented programming, okay, these functions, they are encapsulated within the object itself. Okay. And those functions are known as methods here. So a particular object only contains these members, they contain the methods. So these methods are particular for that particular object type. Okay, this is encapsulation. Okay. This is one of the major difference. There are other differences. So, okay, this is what we'll not discuss anything more today. Okay, then most of you have left by the time, huh? So today let us stop here. Question?
Okay, sir.
Okay. So Saturday will formally end up, okay, and then I will send you some material on C graphics. Okay. So that part I will send you, and in the next Thursday you will have your second test 2. Okay. Syllabus we discussed earlier one was
So earlier one was up to structure of a C program.
structure of C program. Yeah, up to this. So this thing, file IO, C expression, array and string, control statement. So this one would be up to control statement. Okay.
Okay, sir.
Fine. Okay. So let's call it a day. Bye, everyone.
Thank you, sir.
Thank you, sir.
Thank you, sir.